Hello, this is Alex Yazdani. This is a demo for Lab 3 of EE533 in spring of 2025 with Professor Young Cho. In this lab, we had to put together a couple schematics and then simulate everything with a provided test bench. So I'll just start off by going through the schematics that we had to design. The top level is the drop FIFO. This is the most complex one, and it's the top level. We had to add in this dual port memory, which I did using the IP core. And then aside from this, we had to create this Reg9 schematic. What else was there? Just bus merge, a Verilog file, word match. This one uses a bunch of comparators, so we also had to design the comparators. This is just one comparator that uses the comp8 module that's in ISE. And then there's detect 7B. This is the other schematic we had to design. So then we were provided a test bench to simulate, and it took a while to get it working, but if I go here, and there, this is the simulation, and this does match the screenshot that Professor provided us. I'll just let this continue to simulate, and then once it settles, let's zoom out. So yeah, as I said, this matches the screenshot that Professor provided to us. So if you look at the control bits, whether it's input or output, if it's a 1, that indicates that it's a overhead word. So all of these are words making up a single packet. So if it's a 1, that means it's a header or a tail, and if it's 0, that means that it's either not in a packet or it's a word of the actual packet data itself. So if you look right here, this entire thing from 1 microsecond to 5.7 microseconds is one packet. And the system, actually the memory part of it, will store the entire packet, meaning it waits for this part to, this last word to get received before it forwards it. And so you can see right here, this isn't actually a packet, so these words will get dropped, and that's why like this section right here is just in between 2 packets. This is the header of the next packet. So all of these words get dropped. Also, if the FIFO is full, it will drop the bytes, and the packet will need to be resent. But then also, if this system is an intrusion detection system, so if a certain pattern is found, then that packet will be dropped. So if we go over here and look, I think right about here, we see that we get 1 byte here at 65584. It's a word, excuse me. And then it immediately jumps to the next word that's 65602. So there's a bunch of words here. An entire packet got dropped essentially. So let's take a look at what happened. If we find it at the input, we're looking for 84. So 84 is, this is the last word of the previous packet. Then this, all of this, these words get dropped. Then here's the header of the next packet. And then in this packet, we see the number 7, which obviously for the purpose of the test bench doesn't fit in right here. But this is a pattern that's been hard-coded into the test bench to detect and drop the packet if we see it. So if we look here, the end of this packet is 600, and then the start of the next packet is 602. So that's why over here the next packet we see is 65602. That entire previous packet was dropped. And so yeah, that's about it. Thank you. Bye.